Too loud? All right, cool. Hey, welcome to CodePen. This is our third official meetup page official meetup, and there's some feedback, so I should probably move. All right, just please stand by. Anyway, shout out to the New Hampshire contingent. That's it's my place of birth, so near and dear to my heart. Doesn't matter that your state is, mildly radioactive. Yeah. If I choose not to wear a motorcycle helmet, it's my own choice. Should be good? All right, cool. Let's jump in. So, the important stuff. This is Cantina. We are oh God, Clark, you're going to kill me. I forget. Digital design and development agency. We're working on our marketing and branding. We are hiring a few different positions. If you check our site for careers, we're looking for designers, developers, smart, talented people that are interested in technology and how things work. This feedback's going to kill me. Our website is cantina.co. This is Paul. Paul is the co-organizer. Paul is on deadline. Please wish Paul luck while he struggles to get designs out the door. So this is our bathroom pass. Men's room is located down the hall and to the left. Women's is to the left and then down the hallway. You'll need the key fob to get in. If it's an emergency, talk to either David or Paul and we have a spare key fob. Otherwise, it should be over there. When you're done, please return it. And let's see what else. CodePen is, if you're not familiar, a website that allows you to edit HTML, JavaScript, CSS, Sass, all that good stuff live in the browser. We're kind of here to basically learn about different web concepts that are popular and hack around on them. So last time we did an exploration of CSS Grid, which is a cool new layout technique. Today we're going to kind of work through kind of an overview of what makes good web animation, kind of resources for that, which we'll also be posting on slides later, as well as a hack session. If you want, we can also call that a little early and demo the stuff we've worked on. Is that something people here would be interested in doing? Raise your hand, I guess, if that sounds good. Okay, we'll figure it out. Let's see here, internet. There should be signs on the tables. This is how you get onto our guest network. Please do if you want. Otherwise, I guess you're on your own. We have a code of conduct. Our code of conduct is CodePen's code of conduct. We observe it to the letter. These are the organizers as mentioned. This is contact info. If anything crops up, feel free to contact us either in person or digitally or via text. We'll be happy to deal with any problems. We do the social networking thing. This is CodePen Boston. The CodePen team's pretty on that, so they love to tweet out stuff and maybe Facebook. I don't know. I don't follow them on Facebook. Very active on Twitter. Whatever the kids are doing. They're on LO, and that's great for them. And here's the schedule. So we're doing the intro. After that, we're going to have our animation overview, as said, a hack session, and then possibly present. We have beer, we have pizza, we have swag. Please feel free to just kind of get up and go grab something if you're hungry, thirsty, or if you want a cool water bottle. Yeah. All right. So without further ado, let's get David up here.
Hello, testing. We have a signal? Awesome. Y'all can hear me? I'm taking that as a yes. I'm seeing nods in the back. I'm David. I work here at Cantina. Eric already told you about what we do. So let me just keep going. I'm here to talk about animation today. And probably for most of you, probably most of the people, if you're at a CodePen Meetup, you probably write code for a living, or at least have written code. So when we talk about animation, this is probably what comes to mind first, is some form of code. In this case, this is JavaScript. And we tend to think about animation is like, oh, make a button move, or make that thing, switch over to that side, or make this get bigger or smaller. And that's how we tend to think about animation. And so as a result, we tend to think about it in terms of like how we implement it. So code. But what I want to talk about today is actually art, and what animation actually is. And basically what it is animation is not just making something move. It's creating the illusion of life or illusion of reality. It's about how it moves, not necessarily that it moves at all. And so that's what I actually want to talk about tonight, is like ways that you can make your animations seem more real, have personality, just have a certain, like, to project kind of the personality that you're trying to bring through when you design or you code something. So the idea of animation is actually not a new thing. This is a still from the movie Cave of Forgotten Dreams. It's from a cave in France that's 30,000-year-old cave paintings in it. And what's cool about it is that you see this like rhinoceros up here in the corner. It's surrounded by like outlines of the rhinoceros shape to give like the feeling that this rhinoceros is in motion. And you see like the same thing over here. This I'm not sure what it is. Something. It has multiple legs on it to like give the suggestion of legs moving. So 30,000 years ago, humans were trying to take basically a flat image and bring some illusion of life to it. These are some marionettes from ancient Greece. Plato, Aristotle, and Archimedes all wrote about Greek marionettes. So these are from 4 BC. So all the way back then, people were still trying to like add realism in life to inanimate objects. So this is a quote from Brad Bird, who is the preeminent animator of his generation. You may remember him from such films as The Iron Giant, Ratatouille, and The Incredibles. And this is, when he talks about animation, it's not about absolutely recreating reality. It's like finding elements of reality, distilling them down, and then reflecting it in the thing that you're animating. It's really about the essence of life, not about actuality of life. And so, for example, you take Homer Simpson here. He's a very crude drawing. It's just some circles, some lines, and that kind of stuff. But the way in which he is animated makes him feel very, very real. You can show Homer Simpson to a 5-year-old kid, and a 5-year-old kid will like instantly get what's going on. And part of it is the crudity of the drawing, in that it's a very, very simple drawing, but it moves in a very realistic fashion. And what happens is your brain actually like fills in the gaps. That when something seems alive, you project life onto it. And actually what happens if you make something too realistic, the opposite thing happens. It's like, it's nightmare fuel. So like a very crude Homer Simpson in a very paradoxical way seems more real than a very real Homer Simpson. And so probably at this point what you realize is I'm talking about the Uncanny Valley. I'm sure you've all heard of the Uncanny Valley, and that you have this real to fake scale, and that things like you have things like the Polar Express, or you have Governor Tarkin from Rogue One, where you have like these, you see always seeing like these Japanese robots, and they always just like seem really creepy and weird, because they're over here in that they look super realistic, and they move mostly realistic, and there's just something weird and off-putting about them. Stuff like this, SpongeBob, Buzz Lightyear, Homer, those actually seem more real to us because of their distance from reality. And this is actually the part of the curve, when you're animating stuff, this is actually the part of the curve that you want to be in. So when you're talking about like things like buttons and that kind of stuff, that they can actually have more of an illusion of life than something over here on the curve. So basically what you're talking about, to steal a term from Dan Rather, is you want fake but accurate. So what this does, it adds realism and personality to things that you're doing. That a button feels more like a real object if it's animated properly. A website projects a certain personality if it's animated properly. And I'm going to show an example of that. This is a clip from a Pixar movie called Luxo Jr. I only have a few seconds of it, but I want to demonstrate something with it. That if I play this with only a few seconds of time, you immediately know what's going on in this. You see a loving, doting parent. You see an exuberant little child playing with the ball. It's constrained by reality. You see it's like having to drag its cord around. It moves in the same range of motion of an actual lamp. You can show this to like practically any culture around the world. You can show this to little kids. You can show this to old people. You can show this to anyone. And it's like they're immediately going to read what's going on because basically the way in which it is animated gives it personality and it gives it realism. So you might ask, so you might ask, so how do I do this? What are the tricks? These guys figured it out before any of us in this room were born. This is Frank Thomas and Ollie Johnston. They were animators at Disney. They were called part of Disney's 9 Old Men. They're so revered in the animation business that Brad Bird gave them a cameo at the end of The Incredibles. They wrote a book that was published in 1981 called The Illusion of Life. And in it, it was about character animation at Disney, and it was basically, in chapter 3 of the book, they laid out their 12 principles of animation, which are, as the title says, the way that you add an illusion of life. And these are the 12. I'm not going to go through all 12 tonight because we would be here a while. I'm just going to hit on 6 of these that work really, really well for improving the quality of our animations that we put on websites, we put in apps, that sort of thing. The first one is squash and stretch. What this does is, you see how when they hit the bottom of the thing, they kind of like sag a little bit? What that does is it adds an illusion of mass and gravity, that something is actually working on these objects, that they're not just like floating in space, that they're actually being pulled down as they go. It's a very common thing. You see it in a lot of Disney cartoons, and it adds, like I said, it adds like the feeling of mass and reality to the characters. Anticipation is another one. You see this a lot in cartoons, and what it does is you telegraph a major action before it happens. In this case, Thumper's going to run off, and you see him, he like picks up his foot, and so basically it can show several things. It can show enthusiasm. So rather than say like something just sliding off the page, if you put a little anticipation in there, it shows like it's enthusiastic to go away. It can show trepidation. It can actually telegraph emotion. It actually takes the rabbit running away and adds an emotional layer to it. Follow through, that's about physics and inertia. You see as she spins that her dress, her hair, and her arm all spin at a different rate. Her dress, her hair, her arm keep going. It adds the feeling of inertia that real objects have. Exaggeration. This is when we say things are cartoony, meaning that it doesn't have to move in exactly a realistic fashion. You can exaggerate a move for effect. And you can actually step outside of reality, but if you do it carefully and at the right time, it looks really cool. Slow in and out. Again, this is also about inertia, that objects in real life, they start slowly, they go faster, and then they slow down. I'm sorry, this is the creepiest of the GIFs that I have. He's just staring at you. But that adds an illusion that items have weight, they have mass, that they actually move the way real items do. And then secondary action. And what this is when motion occurs in real life, it isn't just one thing. There's like multiple aspects to it. So the dog rolls over and you see his leg drop. It just adds a second layer of reality to what's happening on the screen. And I have a demo. That they say you should never live code, but I am going to give it a shot. Okay. So what I want to do is I have made a very, very simple animation of a bouncing ball. And I want to show how you can apply some of these Disney principles to a bouncing ball to improve it and make it feel a little bit more real, add a little more personality to it, just generally make it feel like a more realistic animation. And so basically, this is a keyframe animation. It goes from 0 to -170 and back to 0. Oops. Helps if I go to the right place. So let me actually, that's a whiteboard that I want to demonstrate. So if we talk about a bouncing ball, I'm going to do a timeline of the bounce. And so like this is start to finish of the bounce. Right now, the way that I have it coded is the bounce is exactly at 50%, which means that it pretty much, it feels very mechanical in the way it works. It just back and forth, back and forth, back and forth. Make sense? So, if you actually have a ball that bounces, when it drops down, because of gravity working on it, if you're all taking physics class, gravity is a constant. Because gravity is working on it, it'll fall faster down than it bounces up. So when it bounces up, it has gravity working against it. It loses some energy when it bounces. So the bounce down will be faster than the bounce up. Does that make sense? So on our timeline, the point where it bounces, we probably need to move it like over here somewhere, so that there'll be fewer frames on the down and more frames on the up. Does that make sense? You follow that so far? Okay, cool. It's pretty simple, so I presume. So I am going to move the timing on the bounce to at 30% of the timeline. And you'll see that, I'm sure this is rebuilt, but now the drop is faster than so that's like a dose of reality. That makes it feel a little more real. So the next thing about it is that when the ball drops, my eraser over here. So when the ball drops like this, and it hits bottom, it doesn't immediately start back up in reality. There's a slight pause here at the bottom when it lands, because it has to stop, the energy has to be transferred, and then it starts back up. That makes sense? So the way I'm going to do that is I'm going to make it basically stop. I'm going to make it stop at 0, 0 for 3% of my timeline. So if I do my timeline here, this little section, it's going to be stopped at the bottom. Does that make sense to everyone? So if I do a rebuild on that, it's not really obvious because it's not a lot of the timeline, but it's enough that it stops a little bit at the top. And so conversely, a little bouncing ball animation, it's there. Conversely, when it bounces back up, when it gets here to the top, it's going to sit there at the top of the arc for a little bit. And it's going to sit here at the top. It's going to slow down, it's going to pause, it's going to sit there, and it's going to reverse. So over here at the top, this will actually be a longer time. So we need it to park at the top maybe about like that much. So this section here will be basically paused at the top of the arc. Again, does this make sense? Cool. So I'm going to actually take this. I'm going to do 85%. Do a rebuild. Now you see that it's stopping at the top. A little bit of a pause there. So another aspect of the bouncing ball. Does this make sense how I'm attempting to model reality? Cool. So another aspect of the bouncing ball is that again, gravity is a constant. So when it drops, it starts up here and it drops down, it goes faster. It starts slow, drops, fast, and then it like hits bottom where it stops. And then when it bounces, goes back up, it starts slow, fast. And so what we need is, and then slow again, obviously, when it gets back to the top. Hey. So what we need to do is we need to add some easing to it. And so actually I have already done this. And so what this does, do you all know about cubic Bezier? Does anybody not? We have several, okay. So what this is a form of animation timing. And there's a website, it's actually in the resources, it's called cubicbezier.com. And what this does, what this over here is, it's progression. So this is movement over time. And so what you can do is you can pull these handles around to add different types of easing. That it will start slow, faster, slow, faster, slow, faster. Because it's distance over time. And so what's really cool about this is that if you're working on an animation, you can go in here and you can drag these handles around, and then you can do a comparison. Board got in the way. And you can do a comparison of the moving, and you can see like how your easing has affected it. The pink one is our easing, and then once you find an easing that works, you can just copy it and put it into your code. You can go do really wild things with the handles, and you can do this, which will make it will slide backwards and then bounce forward. And this is how you can add like really cool bounces and ramps in, ramps out, that kind of stuff to your animation. Is that cool? Make sense? Awesome. So I have added a cubic Bezier to this, which now makes it accelerate as it drops. It hits the bottom, and then it starts slow and goes faster, slower when it gets to the top. So this looks pretty good in terms of how it's moving, but we can actually make it look even more real by adding some stretch to it and some squish. So if you think about it, so what will happen when the ball hits the bottom is when it hits, it'll be round, and then as it carries downward, since it's a rubber ball, it will flatten. So what we can do is, if you actually think about it, we've already got this part where it pauses at the bottom. So this is the part where we can flatten the ball out as it hits. So it will be flat during that part. So I'm going to do a keyframe where it does height. Oops. 15 pixels. Our dot is 30 pixels, so I'm going to make it squish half wide. I'm going to do a width, and I'm going to spell width right, of 38 pixels. And then you'll see when the board gets out of the way that it flattens out when it hits the bottom. But you see that it also is kind of not springing back in a realistic way. So if we continue the way the ball bounces, it will be flat at the bottom, like this. And then it'll go back to round, but because of inertia and just the way physics work, it will actually rebound back into a shape like this as it bounces upward. Plus, from an animation perspective, it'll give that feeling of upward moment or motion and momentum. So what we're going to do is we're going to have the ball as it bounces upward. It's going to go flat, and then it'll go round, and it'll go like this, and then when it hits back at the top, it'll go round again. So we're going to have it flat, rebound into that. Does this make sense? Awesome. And so we have it flat here, and then if about 50%, we want to have it that way. And then by the time it hits 85%, we want to have it round. So what we need to do, we've already set this flat, so we need to set this to be tall and skinny. And then we need to set this at 85% to be round. So I'm going to add a point at 50% where it's tall and thin. Since it won't rebound back as much as it flattened, I'm going to make it like 20 pixels, and then height maybe like 35 pixels. And then when it gets to 85, we need it to be round again, so I'm going to do height 30, width 30. I'm going to save that. And now you have squash and stretch. Adding a dose of reality to it, it feels like it's actually propelling itself upward now. It has the pause at the top, It has the pause at the bottom. It feels like a much more real bouncing ball than the one that did before, which just felt kind of like a machine doing a thing. And I won't actually walk through the entire process of this, but I actually added a secondary animation to it of a shadow that as it drops down, the shadow gets bigger and less opacity. As it bounces up, it goes away. It doesn't really show up well on the screen. But again, it adds a feeling that the ball is actually bouncing into something. Yes?
So I noticed the ball, you put the height and width attributes, but on the shadow you use transform scale. Is there any advantage or disadvantage?
To be honest, I used height and width because I thought it would be easier to follow. That was the only reason. To be honest, transform is probably better because when you use transform, like translate, opacity, scale, that kind of stuff, it offloads the rendering to your graphics card, and it's actually much more efficient. So whenever you're animating, you're always better off using those kind of things and rather than straight up height or straight up position. Because it's actually significantly more efficient in the browser. And so hopefully you're able to follow this, but basically what it has slow in and out, it has secondary animation, it has squash and stretch. These are the kind of things that make your animations feel more real. One of the problems that this has, though, is that it bounces the same height every time, when in real life it would not. But again, this would just be a loader. It would only be there for a few seconds, but it has some personality and realism that, say, just a spinning thing would not. So are there any questions? Did that? Cool. Go back to. I have some resources here. You can actually, if you just Google Disney 12 Principles of Animation, it's really, a lot of people have written about it. This is a really good one in that it shows an animated GIF example of each one. Disney animation examples, that's actually where I cribbed a lot of these GIFs from. This is something I use a lot. It's Annie Collection, github.io, and it has a bunch of pre-made animations on there. So if you're new to animation and you just want to say, like, how did they do this? You can go and you can look at the code and actually see how they put together their keyframe animations. Or if you're just like, I need a box to slide out, you can just go and grab one of these things. You can tweak it, you can adjust it. It's really, really a great resource. Cubicbezier.com, also a really great resource. I put the bouncing ball example up in a CodePen and as a GitHub repo if you're interested in looking at it there. And I'll leave with one thing. I had a professor in college, and one of the things he always said, if you want to be successful, study success. And what he meant by that was that, like, if you want to be a good writer, look at how good writing is done. Find your own style, but it's like you want to essentially like emulate the way good writing is done. If you want to be a good animator, look at good animation and study it and find out how it's done, and your animations will be significantly better. And I think that is all I have. Are there any questions, comments?
Did this, all right, nice. I like half expected that to not work. Okay, so before we break out into a session, just one last little thing. It actually started up, which is lovely. So a bit more on the technical end of things. And again, these slides will be posted, so these are links you can look at. So there are two main ways to kind of go about animating things on the web. They're not necessarily mutually exclusive. CSS can be used to enhance JavaScript. JavaScript can be used to enhance CSS. From Google web developers, which is, at least in my mind, a pretty authoritative source, the way they think about it is CSS animations, so your keyframe animations, your hover states. Basically, you want to do that for simple kind of one-shot sorts of things. And again, as David kind of demonstrated, without bringing JavaScript into the equation, you can get some very sophisticated, very lifelike animations for a very low kind of payload in terms of download and a kind of a very low effort in terms of like the cognitive overhead it takes to build these things. You can isolate it specifically to a component, say as a button. When you have more complicated things, that may be time to bring JavaScript into play, especially in situations where it might react to user input. And this kind of extends a little bit beyond, clicking and more to like, if I'm manipulating values on the fly, JavaScript provides a web animations API to get more sophisticated interactions. The benefit of the web animations API is it's standardized, so everybody can kind of take a look at it and know what they're dealing with. I'm really bad at JavaScript, so please don't ask me about working with it. There are libraries out there, GreenSock in particular being kind of the end-all be-all to really sophisticated web animation manipulation. But again, as David kind of demonstrated, you can do a whole lot without having to bring in a third-party library. So at least personally, the way I like to think about it is, kind of challenge yourself a little bit. What can you get away with before you have to bring somebody else's code to bear? That's nice for making kind of performant, easily understood animations, because usually you're going to be building it for a team and not just yourself. So it's a matter of learning a little bit of CSS versus learning an entirely new library and their entire way of doing things. In terms of people that are talking about web animation, again, it's all on Twitter. Twitter is the best worst thing to happen to coding on the internet as far as I'm concerned. Rachel Neighbors, Val Head, and Sarah Sudin, I'm going to butcher that last name, Sweden, thank you. These three women are just, I would say, like the best in terms of the industry. They're constantly talking about how to make really effective, really performant, really incredible animation. Some other people worth following, basically, if this is of interest to you, follow them, follow the people they follow. When they talk about something, see who else is talking about it. And then in terms of other resources, again, we're going to point right to the things they're talking about. The animation guidelines for UX design is interesting because it kind of takes the human end of it, so when the delight sort of stops and how it can be effective for communicating meaning. Let's see, MDN has kind of more of the crunchy nitty-gritty stuff, so I'll be posting slides immediately after this when we break into working sessions, so if you want to have something to look at, to reference, especially using kind of transitions and animations, and then request animation frame again. So yeah, I think that's the end of the slides. So now let's just either break up into small groups or by yourself, whatever you're comfortable with. Again, pizza, beer, swag, and let's see what we can make. Thanks. Actually, I'm sorry, I forgot one last thing. Before we get too far down to the rabbit hole, does anybody have any announcements? Any looking for a job, have a job, anything going on?
I have a job.
Hello, yes.
Hi, my name is Jeffrey. I'm looking for a job.
All right, what kind of job are you looking for, Jeffrey?
Something that's more on the kind of like straddling the technical and the design side. I come from more of an economics background, and I'm like slowly working my way into coding. So I've been at it for a couple of years now, but I definitely enjoy the design aspect
For sure. Yeah. If that sounds like something they're looking for, meet Jeffrey. Anybody else? Yeah.
Hi. I'm also looking for a job. I'm looking for for a front-end dev role. I work mainly in HTML, CSS, JavaScript. I've worked in AngularJS, and now I'm in React.
Cool. Okay. Same as before, I guess. Yeah. Anybody else? Nope.
I'm Kate. I'm also looking for a job. I need to update my portfolio, but I do product design, a bit of front-end.
Great. And then I think I saw one more hand. Hello, sir.
I'm not looking for a job, but I wanted to share that the Animation at Work Slack has all the people on that previous slide
Oh,
on it, and anyone can join that and talk to people about animation.
awesome.
Some really great stuff going on that side.
What Slack was that again?
Animation at Work, I have CodePen Boston on Twitter.
Awesome. So for those who didn't hear, on the hashtag CodePen Boston, Animation at Work Slack group, of course it's in Slack. Everything's in Slack these days. Yeah. And anybody else? Great. And then one last thing. Amanda is here. I didn't want to put attention on her, but she runs an incredibly good meetup group, Boston CSS. I believe they're on summer hiatus right now, but if this is the kind of thing you're interested in, they have more of that. They have a lot of really incredible speakers coming around, and you should definitely give that a look. So yeah, that's it. Let's get coding.